Hello, Leon. It's your Zayde, Mason. I'm here to continue on with the ABCs of physics. When we last did a video for you, we left off at L is for liquid, and we talked about liquids a little bit and sublimation, but we're going to continue on, and we're going to move on to M is for magnet. Not for Mason, but for magnet. So, a magnet is something that creates a magnetic field, and you see that all over the place. The field pushes and pulls on other magnets and metals, and you can see that the magnet is holding a bunch of nails. The Earth itself is a giant magnet. This is true. And it causes all compasses to point north the way that we design them. So they're little pieces of metal, and they float around, and they are pulled by the Earth's big magnet inside, and they point north or south. N is for Newton. Aha! See, that's supposed to look like Isaac Newton. Not a ball, but Isaac Newton. A Newton is a standard unit of force. Aha! Yes, we haven't talked about units or measurements, but Newton was a person, but we also use him to describe a force, and we will talk about that another time. But it is named after physicist Isaac Newton, who was one of the first. And Newton is famous for his laws of motion, which we will probably eventually talk about Newtonian mechanics, but we'll get to that. And those govern the dynamics of matter under the influence of forces. So, yeah. We will talk about Newtonian mechanics another time, and Newton, but it is a type of force. O is for optics. Ooh, look, we've talked about optics before. Remember, you've got diffraction and reflection and light going in different velocities and based on what energy level it has. So this is how the rainbow gets created from a single white light. Optics is the study of how light interacts with matter. It reflects, refracts, becomes white light, or becomes a rainbow. Optics helped with the invention of eyeglasses, which you may or may not need, but you'll see that your parents and your grandparents, like us, certainly need them. It's also used for cameras and telescopes, and we can talk about telescopes another time. After the quantum nature of light was discovered, the study of optics turned to lasers. Ooh, lasers. We'll have to talk about lasers some other time. But we'll move on to this. P is for photon. Ooh, photons. Photons are really cool. Photons are what light is made out of. Photons have no mass and no electric charge. A photon is the elementary particle that carries electromagnetic force, which includes light, lasers, and X-rays. Interesting things about light is that they have properties which are like matter and like waves, and that goes into quantum mechanics as well. But we'll talk about that another time as well. All right. Q is for quantum. All right, we keep mentioning quantum mechanics. A quantum is the smallest unit of energy. That is another way of using it. But yes, it is a discrete, specific amount, and it is an amount of energy, and it is the smallest amount of energy. It is the amount of energy an electron uses to travel from one orbit to another in an atom. So you add energy to an electron by hitting it with a photon or some electromagnetic frequency, and it jumps instantly from one level floating around the subatomic nucleus to another level. So we add a little energy and poof, it just appears there. It does it through quantum teleportation. We'll talk about that another time. Well, all of these another time. R is for relativity. Ooh, we haven't talked about relativity. The principle of relativity is that some rules of physics are the same for every observer. You'll hear this when you hear a train come by, and you go, meow. That's another topic, and we'll talk about that. But it works the same for sound, or for light, or for other kinds of waves. From this principle, Albert Einstein, whom we talked about before earlier in the book, derived that the effect of gravity is due to warping of space-time. See how there's a planet, it's warping space around it, like the moon is moving around it, but it actually warps space partially due to gravity. This theory has predicted many extraordinary things such as black holes, gravitational waves, and wormholes. And there's a gravitational wave detector up at the observatory near Grandma and Grandpa's house over in Southern California. And we'll talk about that someday. S is for string theory. Ooh, that's a heavy topic. String theory is a new theory for physics. It is. String theory combines quantum theory with relativity to explain how the universe works. It is the idea that everything is made of tiny vibrating strings and rather than pairs of particles like protons and electrons. We talk about infinite numbers of harmonic oscillators. That's such a heavy topic. We will talk about that another day. T is for thermodynamics. Ooh, we've talked about thermodynamics, haven't we? See, we've got different temperatures and it creates work. Thermodynamics is the study of how we can use energy to do work for us. So thermodynamics explains how heat and temperature are related to energy. A famous law of thermodynamics says that heat cannot flow from something cold to something hot. It goes the other way around. That's because it changes potential energy. Uncertainty. Ooh, uncertainty. That's part of the quantum discussion. U is for uncertainty. Uncertainty is when we do not know something. Well, yes, we will. That is true. It is when we do not know something. Heisenberg, we'll have to talk about Werner Heisenberg, Heisenberg's uncertainty principle states that the more we know about where something is, the less we know about where it is going. We'll talk about that in racetracks some other time. But right now, we just got to get through the book and finish all the letters. V is for vacuum. That's like in space. Vacuum is a space that has nothing in it. Well, technically it has quantum foam in it, but we will talk about that another time. Even outer space has some particles floating around it. The idea of vacuum is useful of thinking about what would happen in ideal conditions to carry out experiments. Well, outer space is nothing but vacuum. Well, not entirely. It's got all kinds of things in it, but okay. W is for wavelength. Wavelength is how far apart waves are. Yes, and it has a little bit to do with energy and motion to an extent, but we'll talk about that. Wavelength is how far up waves are. W is for wavelength. Repeating patterns like ripples in water or vibrations on a string, like music. The distance over which the pattern repeats is called the wavelength. We can hear sound waves with wavelengths, and light travels through wavelengths. X is for X-ray. X-ray radiation is high-energy light that we cannot see, but we can use it, like Marie Curie helped discover it, and X-rays are very short wavelengths and can go through our skin but not our bones. So we use this to identify if you have broken bones or look inside someone's body. It's a little hazardous, but we do use it as a tool. Y is for yttrium. Okay, it's an element and it begins with Y. Sure. Yttrium is one of the many elements in the periodic table. It's a very heavy element. Each element in the periodic table has an atomic number based on the number of protons and in the nucleus. Yttrium has 39 protons, very heavy. So it is listed in the periodic table as number 39. And then here's the last one. I know this is a very long video. Z is for 0 point. Ooh, I studied 0 point energy for my thesis. 0 point energy is the lowest amount of energy a thing can have. Before quantum theory, it was thought things could have zero energy. Quantum theory, however, predicts that the lowest possible energy of a thing is not zero, but rather the thing's ground state. This amount of energy is called 0 point energy. I would go into all sorts of other things, but we're running out of time. I love you very much, Leon, and I will talk to you soon with another book, okay? And next one will be shorter. I love you. Bye.